Hi there, my name is Irene, and in this video, we're going to talk about how we create Revit floors. What are the rules that we need to follow, and a few variations when creating floors. So let's get to it. Alright, so I'm going to continue working with the project that I already started. You may notice that I already have my walls and columns, and this is important. So the first thing to understand about drawing floors in Revit is that usually the existence of the walls will determine the placement of your floors. So you need to have walls first, and then you put the floor on them. Now, when it comes to drawing floors, the best way to do it is in the floor plan view. This is in general when modeling most things in Revit. The 3D view is there mostly to help us check that things are coming along the way that we want to. So I'm going to open my floor plan view, and here we go. You can see the CAD drawing. I don't need it for this exercise, so I can actually right click and hide it for the time being. And there are our walls. So floors are going to be in the architectural tab. You can see them right here between the ceiling and the curtain system. And same as with the walls and columns, you can see that there's a little arrow that basically shows you that there are multiple kinds of floors. Once again, we are going to be working for the most part with architectural floors. We do not need to make structural floors. That's for the engineers. And these other elements here are a little bit more complex, a little bit more advanced. We're not going to be messing up with them. So I'm just going to click on architectural floor. Floors are one of those Revit commands that do not have a quick key, but if you find yourself having to draw or edit floors consistently, you may want to assign a quick key to that. And now here we have the creation floor options. You're going to see that there's not as many options as when we're doing walls. For floors, you're not really setting up with height, length. With floors, you're only really going to be doing two things. Number one is set up the floor type that you are creating. In this case, the default is floor generic 12 inches, and that's exactly what I want. I don't want any of these other options. You could set up the level. Now, your level is going to be set by default by whatever view you are in. That's why I like to draw my floors on the floor plan view, because that way the level is reset. The other thing that we are going to do to create our floors is going to draw its boundary. So when you are creating walls, it's just a line that you're drawing, right? And when you're creating columns, you are just placing an object. But when we create floors, you have to draw the boundary of the outline of your floor. So you can use any of these tools here. The best one is actually pick walls, which is another reason why we draw our walls first and then we do our floors. And the idea here is that our floor has to be a closed boundary. Now, when I choose my pick walls option, you're going to notice that all I have to do is click on the wall, and that is going to generate this line. Now, a couple of things to notice about this line. First of all, these double arrows here. If I click on them, it's going to switch my selection from the outer side of the wall to the inner side of the wall. And if I would be working with structural walls, it would basically be flipping from like the core of the wall to the outside of the wall. So why do we have this option? Well, this is the thing that is interesting about working with floors, because the way that you construct a slab will depend on many things. It will depend on the construction method. It will depend on whether your structure is wood or metal or just concrete. But basically the idea in the context of Revit is that usually if you have a multi-story building, what's going to happen is that you're going to want the boundary of your floor to connect to the core of your wall, but then basically whatever exterior finish your exterior wall has should wrap in front of that floor. Now, if your building is, let's say it's a concrete structure, and then it's going to have a curtain wall facade in front of it, then in those cases, we want that floor to end right against the outer side of our walls. It's basically flush, and then the curtain wall system goes in it. If you are talking about a floor that is on the ground level and it's maybe a structural slab, then in that case, your floor will expand beyond the placement of your walls. So in the real world, the position of your floor, the position of your slab will vary depending on the circumstances. Now, in the context of interior design in particular, things are going to be a little bit different. We usually always put the boundary of our floor on the exterior side of our walls. And the reason for this is because usually when you're working with interior design projects, you are probably doing a smaller part of a bigger building. Like with this example here, I am doing a retail space that is part of a bigger mall. And basically what happens when we are building these kind of models is that you can think about the architectural shell, the scope of your work, as a slice of cake. So I think everyone has seen that one person at the birthday party that goes and cuts their slice of the cake like in the middle of the cake, those monsters. So basically here we're doing exactly the same thing. You can imagine almost like you're coming with a knife and you're cutting out just your piece of the project. So because we are doing that, it doesn't really matter where my slab should realistically end. The slab will end where the scope of my work ends, where my architectural shell ends, and that is defined by the outer boundary of the wall. There might be exceptions sometimes, but for most intents and purposes in interior design, we put the boundaries for the floor on the outer side, aligned with the exterior walls. So I'm going to pick the rest of my walls. And one interesting thing that you're going to notice is that despite the fact that my walls end a little early, the floor boundary knows that they need to connect. And this is because the other very important rule when you are creating floors is that you need to have a perfectly closed boundary. That means no gaps, no extensions. So if I, for example, let's say that this line goes here a little bit beyond and this, and then I try to say yes, you're going to get an error message that is going to tell you that my lines are intersecting and that is not going to let me continue. Now, one thing that I really like about Revit is the fact that they will actually highlight the problem areas so you can find and fix it. With other software, they just tell you like, hey, there's something wrong, go figure it. So that's very nice of them. So I cannot have any lines that extend. So if I go here, trim, trim, I also cannot have any lines that are not connected. So for example, here I have a gap. And once again, if I say yes to finish drawing my floor, it's going to tell me once again, no, you cannot. There is a gap. You need to have a closed loop. So those are the basic rules. You also cannot have just any, straight lines. Like if I have a line somewhere around there, again, that is not a part of the loop. That is going to trigger an error. So no matter what the shape is, you want to make sure that you end up with a closed boundary. These double lines here basically indicate the span direction. So basically, if we would be making a structural floor, this is the direction of our joists, but we're not doing a structural floor here, so you can just ignore those double lines. So if you have created a good boundary, when you click here, yes, it will create your floor. Now, you cannot see the floor on the floor plan view, this unless it would have a material applied to it. So this is why we have the 3D view. So now I can come here and there is my floor. Now, what you can see is that it is perfectly aligned with my exterior walls. If my columns would protrude beyond the walls, I would have to have my floor boundary follow them. This is super important. If you don't do that, if your floor only follows the walls and it ignores any protruding columns, your 3D model is going to look kind of weird. It's almost going to look like your columns are just kind of like hanging with their feet out in the air. So you want to make sure that basically your floor boundary covers everything on top of that floor. So one more thing that I want to show about floors is the fact that you can create openings in your floors by having boundaries within boundaries. So basically you have your initial boundary, and now what you can do is that if I want to have an opening on my slab, all I need to do is add a secondary boundary within the initial one. Now to do that, I can select my floor and then come here back to edit the boundary. And now you're going to see that, for example, if I draw a circle here and I say yes, now when I go to my 3D view, you're going to see that there is a nice little hole where I can throw people into the void. Now, very important with these like opening boundaries, you want to make sure that same rules apply. So basically I cannot have these boundary crisscrossing with my outer boundary. That is going to give me, once again, an error message. Okay, so I'm going to get rid of this guy because I don't want to have, a hole on my floor. And obviously there are a few more modifications that you can do to floors. You can, for example, work with slopes for water drainage, but that is a little bit more complex. So I'm going to keep it just to drawing a boundary and picking a floor type. One final thing that I want to point out about the behavior of floors is basically how they are extruded, because you drew the boundary, but that floor has a thickness. So what I want you to notice here is the fact that whatever level you created your floor on, the thickness of that floor will be created away from the walls. So basically, whatever level your floor is in, the thickness of that floor will be extruded downwards always. And this is important to understand because if you're doing a multi-story building, basically what's going to happen is that if this would be a multi-story building, this level here would have another floor. And then that floor will extrude down and eat out from the height of my walls. So when you work with a multi-story building and you're setting up your level has to account not just for the height of the walls from floor to ceiling, so to speak, but also for the thickness of the next slab. Okay? Now, as a bonus, if you want to change the properties of your floor, it's going to be same thing as what we are doing with the walls. In fact, floors are system families, same as walls, same as ceilings, roofs, think curtain walls, stairs. I feel like I'm missing one more, but basically you're going to select your floor, you're going to go to edit type, and let's say that instead of these 12 inches, I want my floor to, I don't know, be 10 inches. Well, it's going to be exactly the same as we did with the walls. You are going to duplicate. Let's say we're going to call this guy generic 10 inches, and then I can go here to edit structure and change that to whatever thickness I actually want to be. I'm going to go okay, I'm going to go apply, I'm going to go okay, and there is my custom floor thickness. And with that, we have reached the end of this video. I hope that you like it. If you have any questions, by all means, feel free to add them in the comments. Also, it would be nice if you subscribe, but otherwise, thank you very much for joining in. Thank you very much for sticking through, and I'll see you in the next one. Have a good one. Bye.